Hello, good morning or good afternoon. This is Marvin Burns, and today we're going to start the would be the sixth or seventh try of 6 million digits of the MRB constant. But instead of 6 million, I've had so much trouble with it, I thought I'd try to break my luck streak and go with 5,555,555 digits. So let's go over to my Digital Storm PC. Where I've got several other computers, or two other computers, hooked up to it. We see here if I can get myself and what we're doing on the same page. Alrighty. First of all, we've got, I closed all the old kernels out and set the preferences the way I've seen that they work best so far. Then I maximized the priority on the local kernel since they were the fastest ones. And opened up all the kernels. And where it says parallel kernel results or status, you see the kernels that are open, the priorities, and so forth. And here's the code for 5,555,555 digits. And we're getting ready to run them. Here's the results from before on 6 million digits, where it stopped at a ridiculously early point. It stopped around 30%, but the last time I had saved it was only 6.5%. But this time let's try, and I'm going to keep bringing these messages about my progress, and hopefully these messages will accumulate in me announcing that we finished the 5,555,555 digit calculation of the MRB constant. If it completes, this will be actually a little more than the 5,555,555, but it'll be at least that many. And hopefully at least that many be accurate. And usually, from what I've seen, is that a little more than that are accurate. And so and I've computed 5 million digits. It gave me more than 5 million digits, and it'll be interesting to see exactly how far past 5 million digits the 5 million digit computation is correct. So here we go. 3, 2, 1. Now, it is launched. The start time is, let's magnify that. Let's see here. Start time is Friday, 19th of June, 2020, 16:22:57. So here we have an old kernel status. Let's erase that one and check on the new one. So I'm going to go over here to kernel status, and there they are. They're still running so far. So you might not be familiar with the MRB constant. I will show you what I know about the MRB constant in a very small nutshell. We'll go over to, after we shrink the digital storm computers, we'll go over to, how about Wikipedia. Let's see here. MRB constant, and let's look at the Wikipedia article on it. So there's the article. You can look it up yourself in Wikipedia on your own computer. Let's see here. The MRB constant is a mathematical constant with decimal expansion 0.187859. It is sequence A037077 in the online encyclopedia of integer sequences. The constant is named after the discoverer, Marvin Ray Burns, who published his discovery in 1999. Burns had initially called the constant RC for root constant. After all, it was a constant from all the roots, integer roots, roots of integers to themselves, to the inverse of themselves. But at Simon Plouffe's suggestion, the constant was renamed Marvin Ray Burns' constant, or the MRB constant. He just wanted to know who, how to categorize it. And the best way to categorize it, apparently to him, was, well, that silly number that Marvin keeps talking about. So, the MRB constant is defined as the upper limit of the partial sums of S of n equals the sum from k equals 1 to n of negative 1 to the k times k to the 1 over k. As k grows to infinity, the sums have an upper and lower limit points of 0.812140 and 0.187859, separated by interval of length 1. The constant can be explicitly defined in the following infinite sums. 0.187859 ... equals the sum of negative 1 to the k times k to the 1 over k minus 1 from k equals 1 to infinity, which also equals k equals 1 to infinity of the subtraction of 2k to the 1 over 2k minus 2k minus 1 to the 1 over 2k minus 1. The constant relates to the following divergent series: the sum of negative 1 to the k times k to the 1 over k as k goes from 1 to infinity. That's how I first thought of the constant. just with that high school idea. I had this divergent series. I didn't even know much about it. I just realized that when I take -1 plus the square root of 2 minus the cube root of 3 plus the fourth root of 4 and so forth, that it became an alternating series. That's how it's divergent. It's an alternating series. It alternates between those two sums of that we mentioned before, 0.18, 0.812140 and 0.187859. Later on is when I found out if you subtract 1 from each term, that you get the series to converge, and it converges to the MRB constant, 0.187859, etc. There is no known closed form for the MRB constant, according to Stephen Finch, nor is it known whether the MRB constant is algebraic, transcendental, or even irrational. So, that's it for now. Hopefully I'll have the discipline to tune in to you, or have you be able to tune in to me on a regular basis. I'll talk to you later. Let's sign this thing out now.